Hi, let's find the value of RT, I1 and I2. RT here is the total resistance or equivalent resistance. Solution: RT or R equivalent is equal to R1 plus R2 parallel R3. So these two resistors, they are in parallel and then in series to R1. So RP is R2 parallel R3, which is same as 4 multiplied by 6 divided by 4 plus 6. We have 24 over 10. So RP, which is same as 1 over R1 R2 plus 1 over R3 equals 24 over 10, which is what? 2.4 now ohms. R total, that is number 1, R total or R equivalent is equals to R1 plus this ROP. So we are going to have 3 ohms plus 2.4 ohms. Therefore, RT is equals to 5.4 ohms. Okay, so our R total is what? 5.4 ohms. Now we are required to calculate I1. I1 is equal to V total divided by R total, okay, from Ohm's law. Now our V total is given, which is our V total is 9 volts, okay, divided by R total is 5.4 ohms. So we are going to have 1.6 amperes, or approximately, let's just say I1 is approximately 2 amperes. Okay, I1 is approximately 2 amperes. Now let's calculate the value of I2. Now to solve I2 using current divider rule. CDR. Okay, CDR. Alright, so this will be I2, or you call it I4 ohms. That is the current through this branch. Okay, so we have I2 or I4 is equal to I1 multiplied by R3. Okay, I1 multiplied by this opposite resistor divided by R2 plus R3. So let's substitute. We have I2 is equal to, our I1 is already 1.66 multiplied by 6 ohms, which is our R3, divided by 4 plus 6 ohms. This is equals to 1.66 multiplied by 6. This is 10. Divided by 10, you have 1 ampere. Therefore, I2 or I4 ohms is equals to 1 ampere. Now I asked to calculate the current here. Let's say we have another current here, current flowing here, that is I3. Okay. Now to calculate I3, we can use two different methods. Now IV, to calculate I3 using two different methods. So two different methods. See what we are going to do. First, I'm going to use current divider rule by CDR. That is current divider rule. What I'm going to do here, I will still have I3 is equals to I1 multiply by root 2. Then you divide it by root 2 plus root 3. This is equal to our I1 here already, remember, is 1.66. Multiply it by root 2. Our root 2 is 4 ohms. Our root 2 is what? 4 ohms. Okay, see it here. Root 2, 4 ohms. So multiply by 4 divided by 4 plus 6. This will give us, so this will give us 6.66 divided by 10. Hence, I3 is equal to 0.66 ampere. Okay. Now the second method to calculate I3, second method here is by KCL. Please subscribe and like so that when I will be teaching more on KCL, you will learn about it. So we are going to use KCL, which is Kirchhoff current law. Okay, Kirchhoff current law. We are going to have here I1 is equals to I2 plus I3. Already we have the value for I1, which is what? 1.66 ampere is equals to our I2 is what? 1 ampere. Then plus I3. So you can easily calculate I3. Now calculate I3 and share it in the comment section. So this is it. From here now, this is incoming current according to KCL. Okay, this is incoming current according to KCL. So this incoming current, this is a node. Okay, so incoming current entering into this node, and this one is leaving. Okay, this is a node, this is leaving, this is leaving. So the incoming current is equals to the outgoing current. Okay, so subscribe, like and share so that when I will be teaching more on KCL, you will learn about it. Okay, so this is how you can easily solve for both ROT, I and I2 as well as I3. Okay, we have to include I3 here. Okay, so first find your equivalent resistance, R1 plus R2 parallel R3. This is the parallel resistance. So RP is just 1 over R2 plus 1 over R3. So when you take the LCM and take the inverse, you have product over sum. Okay, that is for two parallel resistors. Then the R total will be adding the series resistor plus the parallel resistor. You have 5.4 ohms. Then using Ohm's law, you can calculate the current. From there, we are going to use current divider rule to solve for the branch current. Okay, subscribe for more on current divider rules. Thank you for watching.